Hello everyone, welcome to this session on advanced control technique of electric drives. So in this video, we will discuss about the field-oriented control, which commonly called as a FOC. And this topic is a part of our Unit 4 in electric drives and controls for our IEEE students. So let us begin by understanding the fundamentals and importance of this control methods. Let us start with a quick recap of field-oriented control. So FOC enables the decoupled control where the stator current is split into two main components. One is flux, another one is the torque. So this makes the AC motor behaves similar like a DC motors. So using the reference frame transformations, three-phase currents are converted into rotating DQ frames. Here, the D-axis controls the flux and the Q-axis controls the torque, which allows the precision and independent controls. So this mind maps gives you the overall of the key concept involved in the field oriented controls. So this connects the transformation control principles and performance benefits. So keep this mind map as a reference for getting deeper into these concepts. Next is the introduction to the FOC. So the field-oriented control is a high-performance technique used for controlling the AC induction motors. So it works by independently controlling the torque and magnitude flux. By separating the torque production from the magnetization, FOC ensures the efficient motor operations across all the speed ranges. The core principles of this FOC, the core of FOC lies in the vector control. So here the stator currents are treated as a vectors. Though the parameter transformations, a three-phase system is converted into a two-axis system. So this allows the independent control of torque and flux using Q-axis and D-axis components. So by converting these three-phase components into two axis components, we can simplify this simplification, which also helps us to achieve better and dynamic performance. Next is the control transformation. So FOC involves multiple transformation stages. First, we start with the three-phase AC system. Then Clarke transformation convert it into a two-phase alpha beta system. Next, the Park transformation converts it into a rotating DQ system. So finally, the system in the DC light control behaviors, which making the analysis and controls much easier. Next, we can go for the introduction of this Clarke transformation. So the Clarke transformation converts the three-phase qualities into two orthogonal components, which is alpha and beta. So this simplifies the system into two-dimensional forms. However, the values still vary with the time and speed. Next, we can discuss about this Park transformation. So Park transformation is the important step in the field-oriented control. It converts the stationary alpha beta system into a rotating DQ system. So the angle theta represents the rotor flux position, and also this transformations allows the flux and torque component to become independent and enabling precision control. Next is the classification of field-oriented control. So the FOC is classified into two types. One is direct, another one is indirect. So indirect FOC estimates the rotor flux using equations and speed measurements. So it is widely used in the industries. The direct FOC measures flux directly using these sensors or machine parameters. So each method has its own advantages based on the application requirement where we are using it. Next, we are coming to the advantages. The FOC offers several advantages. So it provides fast and precise torque responses. It performs well even at the low speed and zero speed. It ensures high dynamic accuracy and efficient operations. It supports four quadrant operations and handle overload conditions. Overall, it improves the motor performance, and efficient is also very significantly improved. And we have certain references also here. So these are the references which we are using for presenting this PPT, which also includes the standard textbooks, NPTELs, and MIT Open Courseware. So you can also go through these materials for deeper understanding of this field-oriented control. In the next video, we can discuss about the direct arc control. Thank you for watching this video. Thank you.